In this video, we're going to be taking a look at deployments, DaemonSets, and StatefulSets. Now, I was going to try and fit crons and jobs into this as well, but as you can see, this video is already 45-50 minutes long. I'm going to hazard a guess at based on how long it's turning out to be so far. So I figured I'd just do these three first, and then I'll do a separate video on crons and cron jobs and jobs. So the deployment section is going to talk about how replica sets and pods fit into it and how they all know about each other and who manages what. The DaemonSets is going to pretty much do the same thing, but without the replica set section because they don't use them. And then we'll take a look at StatefulSets. Now for StatefulSets, I was going to put that in its own video because it's quite in depth because we need volumes and things like that, but I've left it in this one. We need to quickly deploy a volume manager, for wanting of a better word off the top of my head there. So a way of managing volumes, basically, a way of creating volumes. And we could use local path, but I don't want to get you into the habit of that where we can avoid it. Yes, it's an option, and yes, it's a valid option in certain cases, but for the thing we're doing, it's absolutely not valid. So we're going to just quickly deploy Longhorn just to get a storage class available, and then we'll go ahead and carry on with the StatefulSet. The volume section I'm not even going to go into at all. We're just going to quickly deploy what we need and then move on. We're going to cover volumes in a different video, you see. So yeah, that's what we're covering. Let's get going. To start, we'll get a deployment rolled out. To do this, I'll be using an example from the Kubernetes website. Now, I've already taken you through the explain command, and we could do it that way, but I've already taken you through that, and there's no point. We might as well do it this way. This is absolutely legal behavior in the exam if you want to do that. And, if you want to learn more about the explain command, it's in a previous video. I'll try and link it up somewhere. And yeah, so let's crack on with this. So all we've got here is we've gone to concepts, workloads, workload resources, deployments. So if I just scroll down a little bit here, I can see here creating a deployment. So I'm going to grab this and I'm going to jump over to my IDE, which is there. And I'm going to go ahead and create a new file called deployments.yaml. And I'm going to paste that in, and that's it. So first thing to note is this Nginx version is a little bit old, which is absolutely fine because I fully intend to make this upgradable. So I want to be deploying this as it is, and then I'm going to run an upgrade, show you how we can do rollbacks, pauses, and things like that. So the other thing I'm going to do before we roll it out though is I'm going to add a namespace. So I'm going to put namespace learning. And the reason I'm going to do that is because I've already created the namespace learning. And that's pretty much what I'm going to use throughout this tutorial, unless I need another one for another reason. Let's get that deployed. So we'll do kubectl, apply, f, and then the name of the file, which is 10 po-rc deploy ds.sds, because that's the name of the folder, obviously, and then deployment.yaml. So I'll just go ahead and apply that. Now, if I jump back over to my terminal, kubectl, get pod or po in this case, because the shorthand, as I've explained in a previous video, and then we'll look in the namespace learning. And we should see that that's creating now, okay? So I'll just stick a watch flag onto that. We'll just wait for all of those to come up. While that's coming up though, let's just take a look at the names we've got here. So as we know, a deployment creates a replica set, which in turn gets the pods created. Now these pods have the name of the deployment, which is Nginx deployment. If I jump back here, we can see it here. And then it also has these random letters and numbers afterwards. Now these random letters and numbers are generated as part of the replica set spinning them up, and they will change every single time. So for example, let's just have a look. I think that's all of them up. If I go ahead and just get this particular pod here, let's take a look at this. There it is. And I'm going to go ahead and just delete that pod. So what I'll do in the background is I'll do kubectl get pod learning, and we'll just watch that. And now I'm going to go ahead and I'm going to be deleting this pod. So in fact, you know what I'll do just before I continue on, I'll just grab a different terminal window so I can actually do it side by side. So let's get rid of this, and we'll bring this one across here. We'll do a kubectl get pod namespace learning here, and we will just watch that. So we're going to delete this pod here, this one at the top. And what we'll see is it gets deleted and pretty much instantly replaced. So there's no pod destruction budgets or anything like that in place here. So there's going to be nothing to kind of get in the way, say, and make sure the next one's alive before this one's terminated. It'll just start deleting it straight away, and the replica set will detect that it's down one, and it will bring a new one up in place. And to be honest, there's another thing I could show you as part of the replica set. We'll see the number of available go down, and I'll just grab one more terminal so I can show that. And what I'll do here is kubectl get rs and learning. If we look at this replica set, we have the Nginx deployment here. We have 3 desired, 3 current, and 3 ready. So the first thing we'll notice is these numbers and letters here actually match what's on the replica set just here. And these random ones at the end are the ones for the pod. So these will just get changed as and when, but these ones will always remain the same as the replica set. So we can already see which replica set they kind of belong into. So Nginx deployment is the name of the deployment. Nginx deployment hyphen these numbers and letters is the name of the replica set. And then these last few bits on the end are the pod. That's kind of how it works there. So let's go ahead and delete this pod. And then straight away, we can see it goes down to 2 and then straight back up to 3 as soon as this next one's running. And that's how quick it was. So the image already exists on the node. And if the image didn't exist on the node, it might take a few more seconds, but you can see how quickly that was replaced. Now, in this case, it actually started terminating the pod and then a new one became pending, and then you can see actually it was still marked as ready, and it didn't actually go down as not ready until the next one was almost ready to run, essentially. So you can see it happened that quick. It's hard to spot, but in theory what we can do is actually we can add something called readiness probes and liveness probes and startup probes, and these probes allow us to say, like, start the terminating process here, but don't actually remove it from this readiness until this one's running. So this one would become running, and then it would take it out of the loop essentially and start terminating the actual pod in the background. So that way we can always make sure we've got a certain amount running. But you can see how quickly that changed over there. So that's the pod. What we'll do now is we'll actually dig into one of those pods a little bit further. And we'll do that by doing kubectl describe pod in namespace learning. And then we're just going to grab one of the pod IDs. We'll grab this new one here and we'll just dump a little bit of information out here. So let's have a look. We can see if we go through, we've got the name, the namespace, service account that's being used, the node it's on, its IP of the pod. We can see which replica set it's controlled by. So we can see this here, look. And that actually matches what we've got down here. And if we scroll a little bit further down, it's just a little bit more information about the pod. It's, you know, what Nginx image it's using, the ports that are open, the conditions, so the status of the pods, and a little bit more on events and volumes. We'll get into volumes and events and things like that later, but just a quick note on events, we can see it was successfully assigned to the KS worker 1. The container image was then already present because obviously one of these other pods were running on that node. It then created the container and started the container, and then messages from the kubelet. And that's pretty much it. You'll see errors in the events and things like that, but in this case, it was a pretty successful start. Oh, there was no issues. Let's just look at this a little bit further. We'll do a get pod again, but this time we're going to output the YAML. And if we output the YAML, we can scroll back up to the top here. And now we can see the owner references that we were talking about in the previous video. And this owner reference says that this pod is owned by the replica set. Again, you can see as a kind, it has a name, which is here. So we can actually use this to just grab the replica set that it's owned by, which we already know because we've looked at it here. But if we didn't know, then this is how we can get it, or using the describe command as we saw. And then it has a UUID and things like that. So this UUID is unique to the pod. This UUID is unique to the replica set. How do we know that? Well, I'll quickly show you. So let's get that replica set and we'll do the same thing again. We'll output the YAML. So I'll do output YAML on that. If I scroll up to the top, we can see here that we have the UUID here. 139 it ends, and there it is, 139. So that UUID is the UUID of the replica set. Now, while we're in this replica set, we can see that this is owned by the deployment called Nginx deployment, which has a UUID of this. Well, we already know about the Nginx deployment because we actually deployed that ourselves. But, you know, we can do kubectl get deployment, Nginx deployment in the namespace learning, and we'll output that as YAML. And then if we scroll up to the top of this, you guessed it, there's that UUID ending in BD8. BD8, there it is. So you can see straight away how the owner references work. You can see how something can own something else, and that kind of relationship is defined in that sort of way. Yeah, so that's where that initial relationship comes from in terms of something knowing who owns it. But how does the deployment know about the replica set and the replica set know about the pod? Well, let's take the replica set and pod, for example. We've got a spec here, and the spec has a selector which matches labels of app Nginx. So if we have a look at the labels in metadata for the pod, we have app Nginx. And there's also this other one that's been applied via the deployment and in turn replica set. So when we create the deployment creates a replica set, which then creates the pods. So the replica set, when we create deployment, we add this selector match labels here, and that here gets applied to this replica set. So you can see here we've got the selector, the match labels, and app Nginx. That's this section here from the deployment configuration. But then there's also this pod template hash that's been applied. And if you notice this here, this is actually the bit that's attached to the end of the replica set name. So if we have a look at the replica set name, you can see 855.996F8DBD, and that hash is 85996F8DBD. So if we had two deployments, well, not deployments, but pods, I guess, that had the app label of Nginx, there's not going to be a confusion about which replica set manages it, because there's this owner reference in the pod, but there's also this additional hash here, which is applied to the end of the replica set, which also gets applied to a label in the pod. So the pod label gets added here, and then the label selector gets added here. And that's pretty much all there is to it. This template section here, this is the template for the pod. So we can ignore that bit, but this match labels here, this is the important bit. So this here is looking for these labels in the pod. Now, hopefully that makes sense. If it doesn't, have a look at my previous video. That kind of visually, I draw some really crap drawings and, give you an idea of how that all works together in a visual sort of element. This is just the same thing, but showing you in practice what's going on. So there you have it. There's a deployment, a replica set, and a pod. So all that's left to do now is to show you how to do a rollout, pause it, roll back, and that's about it really. So let's quickly do that with the deployment. Let's jump back over to the IDE. Now this version of Nginx is really quite old. I think we're on 24 now. If I actually type 24 in, my IDE should prompt me, and yeah, there we go. So what were we on? 24 dots. We weren't on Alpine or anything, so I can just do 24, and that, that'll be fine. 1.24 would be fine. It will just give me the latest patch version, and we can just go ahead and apply that. So I'll do kubectl, apply F, and I've written apply twice there for some reason. And I'm going to be applying the deployment. Before I do this though, I'm just going to jump over to the 3 terminals again. And I'm just going to show you the commands that we need. So we've got kubectl, and then we need the namespace, learning, and then we could do rollout, which if we just look at help for, you can see there is history, pause, restart, resume, status, and undo. So let's go ahead and take a look at the status, for example, of the deployment, Nginx deployment. And you can see there, successfully rolled out. So that's cool. We can keep our eye on that. The other command that I wanted was to pause it. So I want to be able to pause it as we go along. So if I actually I'm just going to prep these commands because I might not be able to type them all quick enough for how quick it will actually update. So we'll take a look at kubectl rollout pause Nginx deployment, and then we'll do kubectl get pod and namespace learning. And I'm just going to look for the label app equals Nginx. So this will specifically get the pods that are labeled Nginx. And there you go. And we can watch them. Now, I don't actually need that because these are the only pods running, but I just thought I'd quickly show you that because that's something you can do. So if you say, I want to find the pods with a specific label, that's it. That's it right there. So good. Cool. Okay, so let's go ahead and apply that manifest. So I'll hit enter on that. And as soon as I've done it, I'll minimize this so we can see what's going on. Okay, so I'll hit enter. And we can see straight away, we've started to get some changes here. This will start telling us that something's changed, essentially. And I can go ahead and pause that rollout now. So if I pause that, what will happen is it will stop making changes now. So we can actually see here these pods, but none of the other pods are being deleted at the moment. They're all still there. If we now go ahead and take a look at this rollout, we can see that we're waiting for the deployment, Nginx deployment rollout to finish. 1 of 3 new replicas have been updated. Okay, so should we take a look at the replica sets? So we'll do get rs, learning, and we'll see what's going on here. So we've got 2 replica sets now. We've got this new one here with 6966 and the original one with 8599. We can see the 8599 3 pods there and this new one here. The reason this is useful is because if we were rolling out a new app, for example, we could say the first pod went out and we have a deployment strategy that only allows 1 pod to be changed at a time. We might see straight away that there's an issue with our rollout. So we could pause that. We could do a quick check of the logs, a quick check of everything else if we wanted to. Traffic will only have 1 in 4 chance of failing, and we can go, okay, this is a problem. Let's roll it back. Or we could say, do you know what? This isn't a problem. We're just waiting for it to do X, Y, and Z. We can continue the rollout. So to continue the rollout, what can we do? If we go back to that rollout command, we have resume. And then if I resume that, you can see now we have 2 or 3 new replicas. And if I do that get rs again, we'll see those numbers change on this as well. And eventually, one of them will go to 0, the old one, and one of them will go to 3, the new one. So we'll just give that a couple more seconds. And you can see here, it's not doing them all at once. It's actually doing them one at a time. So it's added this new one, then it started terminating one, then it started adding a new one, then it began the process of termination. And then once that was complete, it completely removed the other one. Then it started the same for the next one. And there we go. You can see the last one terminating now that this one's marked as running. And that's it. We're good to go. That's our replica set rolled out. So now if we take a look at these pods, we'll see 3 new pods. all on the new replica set. So that's great. We have the new version rolled out and our app's running fine and everything's cool. However, now red lights start alerting everywhere and telling us that there's a problem with the app. It's not working the way we want it to. No problem. We can undo what we've just done. So how do we do that? Well, let's take a look here again. We've got this replica set here. We've got this new one and we've got this old one. The old one is still there. You know, it's not been deleted and it's still got the setup for the original pods that were there. It's just not active anymore and all traffic is flowing through to the new pods. So we can just roll back to this one, right? That's pretty much it. So let's take a look at that rollout command again. What have we got? We've got history and undo. Those two look like pretty useful commands. You can view the history and you can undo to a previous rollout. Let's start by looking at the history. So here we go. We've got a revision here of 1 and a revision of 2. So if we want to roll back to 1, we can simply do the undo command. So let's go ahead and look at that undo command. We can undo a rollout. We can undo a DaemonSet as well, for the record. You can actually do that as well. And we basically want to roll back to a previous version. So how do we do? We say to revision and then the number. Brilliant. So let's go ahead and have a look at actually doing that. So let's undo that. We'll go to undo. Now, if we undo on its own, without anything else, it will just roll back to the previous version. If we do it with to revision, and we had 4 versions back we wanted to go to, then we could do that too. But just running it on its own, that's absolutely fine. So let's go ahead and take a look at that status again. And you can see before I'd even finished talking, you know, it had already rolled back to the previous version. So that's great. Can we roll back to the new version? You know, we've rolled back. So we've got that history. Can we just roll back again? Well, technically, yeah, because the new replica set is still there. And that was revision 2. And revision 1's gone now because revision 1's become revision 3. So it's not technically rolled back. It has rolled back to the previous replica set. Let me rephrase that. It has rolled back to the previous replica set, but it has created a new revision. So if we roll back again, we'll actually end up back on the new one, which was number 2. Hopefully that makes sense. Let's just show you that as well. And I'll show you with the to revision equals 2. So we're watching those and you can see straight away, these new ones start coming in. And look how fast that's changing. You know, because all the containers have been pulled, there's no messing around. They're ready to go already. Look at that, bang. Straight away up and running. All right, okay. So some pods might have readiness and liveness probes. That means it takes a bit longer for things to come up. But if you are just literally spinning stuff like this, then you know, you can switch back and forth as much as you want. And if we just look at that history once more, we've now got revision 3 and 4. So we're back into the same position we had with 1 and 2. So it can get a bit confusing. Obviously, if I decided to do another change, such as, I don't know, changing the version here to 1.23 instead and applying that, then we would obviously see a new revision coming. And so let's take a look at the status of that. So this will come in. These will start terminating in a second. This will get changed, a new replica set will get rolled out. And I think my connection went a bit funny there, so I've just restarted it. And yeah, you can see everything changing there. And if we have a look at the history now, we should have 3 revisions. So this was the original one. This is the latest one, the brand new version of Nginx, and this is 1.23. And that's rollout, pausing, and undoing, essentially. So this is where it can become really useful if something goes wrong in a rollout. You can always roll back. So now we'll take a look at a daemon set. With the daemon set, as I said before in the previous video, it runs a pod on every single node. So there's examples for that here. You know, I'm on the DaemonSet page now. I've just dropped down to that. And the example that they're giving us is to run FluentD on every single node, basically. And FluentD is there for collecting logs and chucking them somewhere. For example, in this case, Elasticsearch. I don't have Elasticsearch cluster or anything like that, but this is the scenario they're given here. We're just going to quickly copy and paste this, same as we did before with the deployment. And I will just jump into my IDE here and we'll open up a new file and we'll call it DaemonSet.yaml. And I'm going to go ahead and paste that in. Really quickly, we'll run through it in the same way. I'm going to leave it in learning again. You might want to do something like this in Cube System if you're doing it in reality or its own dedicated namespace, but in this case, I'm not going to be doing that. We're then going to just step through again. So we've got this match label selector here, which we'll get into shortly when we actually deploy it and have a look at the pods and the daemon set itself. And then you've got the template for the pods here and the containers and resource limits and requests. So resource limits and requests, again, we'll cover more later down the line, but just as a quick overview, we're saying that it can use no more than 200 megabytes of memory and it requests 200 megabytes of memory and 100 milli CPUs. So that's kind of like 0.1 of a CPU. Best way to look at that. So if I had that as just 1, that would be one CPU thread. By having 100M, that's like a tenth of the thread, essentially. And then it does a volume mount. We've not talked about volume mounts yet, but for now, all it's doing is accessing the nodes var log directory. So this is using something called the host path. And what it's saying is I want to mount this host path var log directly into the container at this location var log. That means that this pod can access all the logs on the node. And that's it. Termination, grace period seconds isn't relevant really here. I can actually delete that. It wouldn't matter. But yeah, again, not going to get into that one right now. It's not relevant. It's just part of the copy and paste that I put there. These here allow us to deploy to nodes that are tainted. So again, taints, we'll cover them properly in a later video, but just a quick reasoning about why this is happening. When I deploy anything onto this cluster, none of them land on the control plane nodes. They all go onto the worker nodes. These taints here allow us to go onto the control plane nodes. In fact, you can see it here. That's essentially what it's saying. It allows us to run on control plane nodes as well as the worker nodes, which makes sense for something that collects logs. You want to collect it from every single node. So that's why these taints exist. If I remove them, it would only deploy onto the worker nodes. But in this scenario, I want it on all of them. And yeah, that's it. So let's go ahead and apply that. We'll just delete that there and change that for DaemonSet. And that's been applied. So we'll jump over to our terminal and grab the other one as well. And we'll do kubectl, namespace learning. You can see the flags go in any order. It doesn't really matter. And you'll see me swap and change, but just ignore that. It's fine. So I could type DaemonSet out every time, or I could just type DS, which is what I'm going to do. So I'll also do kubectl get rs learning. And you'll see here, there is no replica set for a DaemonSet because you don't need one. So a deployment deploys a replica set so that a replica set can manage how many replicas of a pod there are. With a DaemonSet, there is one pod per node. That is it. It can't be scaled up. It can't be scaled down. Okay, so you don't need that replica set. So you won't see them. What we'll have is pods. So we'll just grab the pods. And again, remember this K here, it's an alias that I've got for kubectl. If you don't know how to do aliases in bash, go and have a quick look, but that's all that is. And over here, we'll go ahead and run kubectl get pod, and that'll be in the namespace learning. And we'll see, yes, the Nginx deployment's still there because I never deleted it, but I've also got these pods here coming up. And this is actually taking quite a while to come up. There are ways of speeding up pod deployment. So there's something called lazy loading that you can do with containers. Absolutely not getting into that in this video right now, but if you want to have a little look into it, have a look. It's a great thing to do. Anyway, that was a bit of a sidetrack. So let's just have a look. Yep, all of them are up now. So we should have 1, 2, 3, 4, 5. And yeah, okay, I thought I had 6 nodes. I have one node not ready. Interesting. I'm not going to troubleshoot that right now. I'll have a look at that for the next video. But as you can see, it doesn't matter that I've got a node now because, well, who cares, right? I've got 3 nodes. That's the whole point of having high availability. Here it is in action. In fact, you know what? I will troubleshoot that node. So what I'm going to do, sh u12 192.168.0. I think it was 201, if I remember rightly. That should be control plane 0, so it'll be 202. And if this doesn't connect, I suspect what I'll need to do is actually just reboot that node. Let's have a look. Okay, so I can actually see here on my VM, it's having some problems. It's a little bit unhappy and it's going to start out of memory in soon. So what I'm actually going to do is I'm just going to send the shutdown signal and I'll bring that back up. So we'll just get that killed. And in the meantime, we will carry on with what we were doing. So in fact, that doesn't seem to be working. So I'm just going to power that off altogether. And then I'll power that on in the background. And what I'll do is I'll just export my kubeconfig, because that's a new shell. And then I will do kubectl get nodes, and I will watch them. So this should become ready once that node's rebooted and come back up. But I don't think there should be an issue with it in the background. So we'll see what happens. Oh, there you go. Straight away. Bang. There it is. And that's just become ready. And we should actually see that this has actually just gone up to 6. There we go. You can see it's got, yeah, that's brilliant. So you can see how DaemonSets work. As soon as a new node comes in, a new pod gets created. It just goes, oh, there's a new node there. Create a new pod. So that's the first thing to know about DaemonSets. I'm kind of glad that happened because you saw how they work in action there. So, you know, it's good when bad things happen and it works out for the best. So yeah, there we go. There's a DaemonSet in action. So let's have a look at the actual DaemonSet itself and then we'll have a look at the pods. So I'm going to have a look at this. We'll do kubectl get ds learning, and then the name of it. So we'll do that and output YAML. So I'll do the same for that and we'll do output YAML. Okay, so if I scroll up to the top here, we can see straight away that we have these owner references again, and this owner reference refers to the DaemonSet Fluentd Elasticsearch, which is, you know, it's the one we've just deployed. And we've also got the labels. So let's have a look. We've got a name of Fluentd Elasticsearch. We've got a controller revision hash of this and a pod template generation of this. So let's go over and have a look at the DaemonSet and see what's going on over there. So if we have a look, we've got the label selectors here. So we've got a selector, match labels, and this just looks for name, fluentd, Elasticsearch. So as long as it's got this name, then we're good to go in terms of a label anyway. So the label name is equal to fluentd Elasticsearch. And that's basically it. The DaemonSet knows who it manages by that label selector. The pod knows which DaemonSet it belongs to because it has these owner references. And that right there is how a DaemonSet works. So it comes upon every single node, which we just saw because of that faulty node and when that came back online. And we can also see how they reference each other, the pods and the DaemonSet. So that's how the relationship works between those two. And yeah, that's all I'm going to go through on the DaemonSet side. Finally, we're going to move on to StatefulSets. So to do StatefulSets, we're going to need one quick thing first. We're going to need a storage class, a system to have for storage. Now, we could set up local volumes and go through the rigmarole of that, which, you know, would meet what we need in terms of requirements for now, but I'm just going to make it even simpler for us. So what I'm going to do is say, jump over to your browser. I've already got this example of Cassandra on a StatefulSet there on the Kubernetes website. So we'll be using that to actually deploy this. But before we even do that, we're going to take a look at Longhorn storage. For example, if we just type that, we should come up with that. And we should have a nice, easy deployment method. So let's take a look at the docs. In fact, we'll jump over to GitHub, take a look at the deploy and Longhorn YAML. So I'm just going to go ahead and deploy this. This will create a namespace, a service account, a few more config maps. It will create some custom resource definitions, a few deployments, and basically set everything up so that we can use storage. That's all I'm going to tell you about this for now. Storage is quite a big topic of its own, and to get into it in this video, we'll expand it by quite a bit. So all we're going to do is click raw, grab that, close it, and then we'll just go ahead and do kubectl apply f that. Now this will take just a minute or two to get going, so I will speed up time and meet you at the other side. Okay, so I cannot wait to get my gigabit broadband because that took nearly 10 minutes to come up because every single node had to pull all of these containers. So obviously you can see there's 3, so there's 1 for each worker node, and every worker node on my PC was being hammered, which means, oh yeah. Anyway, now that's all done, we should be able to carry on. So let's crack on and actually roll out the Cassandra StatefulSet. So let's get to the meat of this section. Here we go. There's a lot of preamble here. There's a presumption of using Minikube here, so we'll have to change a couple of bits. And then there's this bit about creating a headless service for Cassandra. Now, a headless service basically doesn't do load balancing and doesn't have cluster IP. It can or cannot do DNS lookup internally. So in the cluster, there's cluster DNS, and it's usually something like, there's a couple of ways of doing it, but for one example, there's the service name dot the namespace dot svc dot cluster dot local. You'll see that in a minute when we come to set up the Cassandra section. So this will still do DNS bits essentially, which is what we want, but we don't want the cluster IP because we don't need it, and we don't want load balancing because we don't need it. We don't want load balancing happening between a Cassandra setup. We want to be able to hit the nodes directly. That's essentially what's going on here. We will get into services again later, don't you worry about that, but for now we will go ahead and create a new file here and we'll call it sts.yaml. We'll paste that in. And rather than creating a bunch of files, we'll just paste it all into one and separate out the YAML sections. So we'll just scroll down a bit further, and then we've got this next bit, which does the StatefulSet, and I believe it does a storage class at the bottom. Yep, that's fine. We might not need that storage class. Pretty sure Longhorn just sets one up as part of it. So kubectl get storage class. Yep, Longhorn set one up for us already. So this is the default one. So if we don't define a storage class, this is the one that will get used. But just for the sake of making sure we actually hit it, we're going to go ahead and do Longhorn. And we don't need that storage class at all. We can change the storage class name here to Longhorn, and that'll be fine. I'll explain this in just a second, and we'll scroll up a bit further, and we need to change this here. This is that cluster DNS I was talking about. So we've got the service name, sorry, the pod we're going to hit essentially, dot the service, dot default, dot service, dot cluster, dot local. We'll cover cluster DNS later anyway, so don't worry about that, that's fine. All we need to do is change this to learning because it's going for the default namespace, and we're in the learning namespace. And on that note, we also need to set the namespace here. So we'll go ahead and do that. and we'll set it on the service as well. And that should do it. So let's just go through and see what's going on here. So we're setting up a headless service, and then we're setting up a stateful set, you know, bit label selectors going on again, number of replicas we want, the image ID, the image we're using is from Google samples apparently. So this isn't a official Cassandra image, I guess, but it's fine for what we're doing here. There's a few ports being set up here for Cassandra's communication, as well as the one that's going to be used via the headless service to be able to use CQL to query the cluster. And we've got some resource limits here. I'm not going to set those because I don't want to hit my limits of my nodes. I'm just going to let them be free. Don't do that in practical production terms. You always want to set resource limits where possible because, like I said, it will just run free. You know, if my Cassandra cluster decides it's going to start using 100 gig of RAM for some reason, then it will just do it because I've not set any resource limits. And then you start hitting the problem of noisy neighbors. And this is a problem we used to hit in VM worlds where too many VMs were dumped on one machine and one VM would start hammering the host's resources and other VMs would suffer because of it. This is the same problem you get here. By using resource limits and requests, we can minimize the impact of things like that happening. Not completely remove it because that's probably impossible, I'm going to say, but it will absolutely reduce it if we set resource limits. We've then got a security context, a bit of lifecycle bits. This lifecycle is just saying what it wants to do. If a container stops, it will run these commands, okay? And if you don't know anything about Cassandra, don't worry about it. It's kind of like draining a node from your Kubernetes cluster. This is a similar sort of thing. You're draining this particular node, or pod in this case, from the Cassandra cluster, okay? So this just gets run every time a pod goes to stop. After that, we've then got a bunch of variables that we don't need to worry too much about. Again, if you know about Cassandra, you'll know what these are. If you don't know about Cassandra, don't worry too much. And then we've got the readiness probe. So this is just something that's being run to make sure the Cassandra cluster is up and running and responding as it should. And this script, I imagine, is in the pod, which is just, you know, being run to check to make sure everything's ready. Once that comes back as okay, this will be marked as ready and the pod will show us ready. Volume mounts, what's going on here? So this is the location in the pod where the volume is going to be mounted. This is a volume claim template. So there's something called persistent volumes, which are actual volumes themselves, like disks, if you like, and there's persistent volume claims. And the claims are a way of saying, I want to claim that volume there, okay? Long story short, this is a way within StatefulSets of creating a persistent volume claim via a template, and it will generate persistent volume claims, which will in turn create volumes using Longhorn, and that will then get attached to the pod. We are going to get into volumes deeper in another video, as I said, when we started doing the Longhorn bits. So don't worry about that too much for now if you don't get what that means. Let's go ahead and do kubectl, apply F, and we're going to do 10 STS. Okay, so let's just jump over to our terminal here. We'll do kubectl, and we'll do get pod, namespace learning, and we're going to watch that. Okay. In fact, you know what we're going to do? We're going to do something a little bit different this time. We're going to do pod, PVC, PV, and we'll do SES as well, just so we can see all of them. And we'll, instead of doing the -w for watch, we'll do watch 2. What happened there? Oh, I didn't put a space. Okay. Oh, wow. Okay, that went wrong. Let's just rerun that command. So watch n2 kubectl get STS po PVC PV namespace learning. Okay, so persistent volumes and storage classes are not namespace in any way whatsoever. They are cluster scopes, which means anything from any namespace can access those things. So yeah, the persistent volume isn't actually a namespace. We don't need a -n learning on that, but we can still get hold of it regardless of the fact we're providing a namespace. So let's run that. No resources found. Brilliant. That is a good start. So let's go ahead and run this. We should see service created and stateful set created. In fact, I am missing something there, the service. So we'll just run that as well, add that in there. And let's take a look, see what gets created. So we've got a stateful set that wants 3 pods. So the first pod's being created, and you can see straight away it's Cassandra-0, not Cassandra- some random string of letters and numbers. So that's where stateful sets are different. And if Cassandra-0 gets deleted, a new pod will come in with the name Cassandra-0. And that's why it's really good for things like Cassandra to use stateful sets, because it means that should that node, let's imagine that pod is a node, get removed, a new one can be brought back in its place and it can carry on back in the cluster and work as it should. That's running. That's a good start. Now that readiness probe will be running, that script that we mentioned. And as soon as that's run and Cassandra's responding, up and running, this will get marked as 1. And then the next node will start to come in. And that next node or pod will not come in until this is running. Our service is there. The persistent volume claim was there. Oh, there you go. That's just gone to running. So this is now pending. The persistent volume claim's there for both of them. And then you can see that a volume was created as well. And you can see that the persistent volume claim is attached to this volume, which you can see is this volume. And that's using the storage class Longhorn, so that's good. That means Longhorn's working as it should be doing. We're getting volumes created. And yeah, okay, so yeah, we'll just give that a minute to come up and be running. So this is working as I would expect. So this is good. So we'll just wait for Cassandra-2 to come up. And then I'll show you what happens if you delete one of those pods. And there's the final pod starting to come up. So this is obviously really good. This is exactly what we wanted. And this means that our Cassandra cluster will be up and running in a few minutes. So happy days. The Longhorn worked as I was hoping it would, because to be honest, I hadn't actually tested that. I was just hoping based on previous experience that it would just work on this cluster. So, you know, I'm glad that did. Brilliant. Okay, so that's all up and running. So I'm really happy with that. That's worked exactly as it should have done. So let's go ahead and start killing a pod. So we've got these 3 pods. I'm going to go ahead and just open a new tab. And in here, I'm going to do kubectl get pod learning, and we will watch that. So let's see what happens here. We will go ahead and do delete pod. And we'll do Cassandra-1, for example. Let's go ahead and delete that. So we'll delete that pod. That'll start terminating. So that's terminated. A new one's coming in now to replace it. And you can see Cassandra-1 got deleted, but a new pod's come in with the same name, exactly the same name. Okay. And now if we go ahead and do kubectl logs f Cassandra-1 in namespace learning, we can see this will start to come up. Give it a few minutes and this will mark itself as ready. And it will be as simple as that. There you go. It's running already. It's back into the cluster. The cluster is now up and running. Look, started listening for SQL clients. That's how quick that came back in. You see, even with its readiness probe to make sure everything's up and running, it just went down. It came back up. The same volume that was on the original pod got attached to the new one. And because of that, this node was able to come up straight away. That's why it's important with StatefulSets to keep the same volume attached to the same pod. Even if a pod gets replaced, the original volume will get attached to that pod again. And we can prove that by doing this. So we'll do describe pod and we'll do Cassandra-1 and we'll take a look at the volume that's attached. You can see here, claim name, Cassandra data, Cassandra-1. Okay. Am I going to delete that again? And once that's gone, give it a second. We'll describe the new pod that's coming in. And we know a new pod's coming in because we've just seen how that works. You can see there, look, session terminated. You can see that draining that's happened. So it started draining the pod. And now we're just going to go ahead and check, make sure a new pod's coming in. So you can see Cassandra-1 there. Let's go ahead and describe Cassandra-1. And we can see again, that same claim, the same volume is attached to that same pod. And this is the second time I've deleted it now. Third time it's going to be coming up. And you know, there you go. So back up and running again. And we can see if we have a look at logs, started listening for SQL clients. That is the beauty of StatefulSets. It's very, very useful for having state in a cluster. And Cassandra is one of those examples. There you go. So that's StatefulSets. And I think that's where I'm going to leave it. And there we go. Hopefully that made sense. If you match it together with the previous video, it might actually help if it didn't make sense. If it still doesn't make sense with those two, well, I'm sorry. Hopefully other videos will clear that up. Speaking of other videos, I'm not sure how many I'm going to get done over the next couple of weeks. I tried to do like 5 before I even started this video, so I always had some leeway. But then I decided to chuck a load of videos out in the first couple of weeks because they correlated to one another. So I've actually ended up with no videos in the pipeline. So I need to get some ready. But right now, I'm literally doing these the day before they go live. I'm kind of firing them out. I'm literally sat here Saturday evening for this to go out at midnight on Sunday. So yeah, we'll see what happens. But I am in the middle of moving house right now. So by the end of this month, I'll have moved. And it might be the start of May before stuff starts to get back into the normal flow of things. I'm going to try and get some stuff done over the next couple of weeks, but we'll see what happens. So if I don't see you for a few weeks, see you in a few weeks. If I do see you next week, then clearly I got something done. I'm also going to be at KubeCon next week, so there's a very slim chance I'm going to get anything done, but we'll see what happens. Either way, I'll see you in the next one.